Problem number 14. At the beginning of 1990, the population of rabbits in a wooded area was 250. The function above was used to model the approximate population P of rabbits in the area T years after January 1st, 1990. According to this model, which of the following best describes how the rabbit population changed in the area? Well, this function is a typical exponential growth problem, and we're looking to see whether the population doubles every 4 months, triples every 6 months, doubles every 36 months, or triples every 24 months. I think this came out very clearly in class that you really want to use an estimation and approximation in working with this function here. So for example, if you were to first use 3 as an approximation for 3.04, then you would see that the original amount of 250 would triple whenever the exponent of t over 1.98 became 1. Because 3 to the first power is 3, and 3 times 250 would give you 750. So whatever value of t would make that exponent equal to 1 would give you a tripling effect. And once again, we're going to approximate, and instead of using 1.98, we can make that 2. And when we do that, you can see that when t is equal to 2, then 2 over 2 becomes 1, and 3 to the first power would become 3, and you would triple in t equals 2 years. Recall that t is measured in years here. So in 2 years, that quantity would triple, and so that is equivalent to the rabbit population tripling every 24 months, which is 2 years. Now, in the event that we didn't see that, of course, that could be solved very rapidly using that method there. And I'll just go through the algebraic way that we could solve this problem, though it would take a little bit longer. We're working with either doubling or tripling. So doubling would be 500. That is doubling the initial amount of 250. When we divide both sides by 250, we end up with 2. Now note that if we had started with 750, the tripling, that value would just be 3 there. If we take the natural log of both sides and use the properties of logs on the right side, and finally solving for t, we would get, so plugging that one into the calculator, we would get 1.234, which is roughly 1¼ years, or 12 months for 1 year, 3 months for ¼ year, so about 15 months. It would double in 15 months. But we don't have an answer like that. So if I wanted to try this for tripling, the only thing I'd have to do is change that 2 to a 3, and I get 1.95, which is roughly 2 years. And so it would triple in 2 years, which is 24 months. So that's another way that you could have gone about solving it as well.